Everyone, and welcome to a video on simple electrical circuits. Now, I know you're all itching to go out there and build your own robotic armored suit, but before you do that, you need to know a little bit about the basics of electrical circuits. And although I can't promise that after this video you'll be able to make your own suit, but I can guarantee that you'll be that much closer to knowing how to make your own armored robotic suit. So let's get into it. So, what is an electrical circuit? An electric circuit is a pathway that an electric current can flow through. Electric circuits have a power source, like cells, batteries, or a generator, a conductive pathway, and an output device that does the work using the energy, in this case, the electrical energy provided by the power source. So, in this case, the cell over here is the power source. The wire is the conductive pathway, usually made out of a conductive metal like copper, and the light bulb does the work by converting electrical energy into light energy. So let's take a look at the basic electrical components, right? So if we start with the power sources, we have a cell, not to be confused with this cell or even this cell. No, this is an electrical cell, and electrical cells their function is to convert chemical energy into electrical energy, and the symbol for these cells is shown below. As so, it's a long line which is symbol or which is represents the positive terminal of the battery, which represents this side of the battery, the cell, right? So it is the long side represents the positive side of the cell, the positive terminal, and the short line represents the negative terminal of the cell, and that's the symbol. Then we also have batteries, and batteries are when we put two or more cells together. So you can see that there's actually two cells in here, and we symbolize batteries like this. You'll see that it's actually basically just the symbol of a cell, but now there's two of them. You can see there's the negative terminal, the positive terminal, then followed by another negative terminal and another positive terminal. So it's basically two cells in one, and that is what a battery is. And that was a 9-volt battery you saw in that image, but you also get larger batteries like your 12-volt car battery that usually has 6 cells. All right, then we have generators as well, and a generator is another type of power source. It uses magnetic induction, so it uses a magnetic field and a moving copper coil to generate electricity. And just for interest's sake, there's the symbol below. Then we have a wire, and our wires are usually made of conductive material like copper, as I mentioned earlier, and the symbol for wire is a straight line. So if you want to draw or represent the wire symbol correctly, you need to use a ruler to draw because it is a straight line. And then we have switches. When the switch is off, when the switch is off, then we say, let me use purple for this one. When the switch is off, then it is open, or it's shown as a open switch when we symbolize it. So a off switch means that the switch is open. It means that the electric current cannot flow because there's a gap in the circuit. That's why switches are also called circuit breakers, because they break the circuit, right? Allowing or stopping the flow of a current. And when the switch is on, as you can see here, when it's on, then we say that the switch is closed. It is a closed switch, which means now the current can flow through the wire once again, because there is no gap as like what we see when the switch is open. So open means the switch is off, and closed means that the switch is on. Right, and then we have different kinds of switches. We get toggle switches, like we can see here. You get a push switch, which works with a button that you push down, and when you push it again, it opens the switch, turning the circuit off or turning the current off. And you also get a flip switch, which is typical of our light switches that we find on the walls. And you also get this unique switch, which is a mercury switch that uses the liquid mercury as well as gravity to do its function. Then we have our basic output components of output devices like a light bulb, which functions to turn electrical energy into light energy. The symbol's given below. Then we have a buzzer that turns electrical energy into sound energy. The symbol is as below. And then we have a motor that turns electrical energy into kinetic energy, and the symbol is given below. But there's actually way more electrical components and symbols than what I've shown you. But that's just the basics that at primary school or at an elementary level you should know. These are the others. You can take a quick look, but if you, like I said, if you're in primary school, you're not required to know these yet. All right, so let's take a look at circuit diagram. So a circuit diagram is the symbolized representation of a real life circuit. So this is what a circuit would look in real life, more or less. This is actually animated, it's drawn, but it represents how more or less what a circuit, the devices would really look like. So this is how a light bulb would look like, a cell, and this is a self-made switch, right? And there's the wire. But to represent it in a circuit diagram would be to draw it only using the symbols. So this straight line here is the wire you can see over here. The cell is represented over here. Well, this is the representation of the cell that you can see over here. The switch is, you can see here, except the difference is that this switch is closed and this switch is open. So although it is the symbol, it's actually drawn wrong here, but that's because I couldn't find the correct switch or the drawing to match my other drawing, the more realistic one. And then we have a light bulb, which is this is the representation of the light bulb that we can see over here. So the reason why we have circuit diagrams is because they provide simplicity, and also it makes it easier for specialists like electrical engineers to represent their circuits or to understand the circuit's pathways and its functionality, right? Because if you look at this circuit over here, you see that it is quite complicated, and for you to draw it without symbols would be very confusing. It would really confuse anyone, I'm sure. So now that that's out, or now that we got that part, now let's do some practicing, right? So I've taken I've taken a section or a question out of one of my worksheets for us to practice on, and this one says, or it's basically an instruction to do a circuit diagram, and it says this one needs two cells, right? A light bulb, a buzzer, and an open switch. So let's do that. Let me use white, right? And then let's start. I like to start with the cells, so I'm going to do my two cells, right? There's one. Okay, there's my positive terminal, there's my negative terminal. What you must be careful of doing is doing this. So you'll see, I'll tell you why now, right? So there's my wire that I'm connecting. Please do not draw the wire like me, freehand. You need to use a ruler, but I don't have one, so I'm just doing freehand. Oh yeah, so I was saying don't do this because what I've done is I've connected them wrong on purpose to show you, because now what happens is the current won't flow because now we have two negative terminals facing one another, which will basically stop the current from flowing. What you need to do is always make sure that when you draw a circuit diagram, or when you draw the cells or batteries in a circuit diagram, that you always alternate between the negative and the positive terminal. So now after this, I would have to have another positive terminal and then my negative terminal for my cell. So there we go. Now the current can flow, and now I'll continue. So then I need a light bulb, which I can put over here. Once again, please do not draw freehand like I am doing, because you'll end up having skew lines, which is not actually the symbol for a wire. A wire is straight line. And then we have our buzzer, right, which is sort of like a barbecue stand or a wine glass, I guess. Right, there it is. That's my buzzer. And then it says I need an open switch. Oh, that Y is so skewed. Oh, don't do that. Okay. Right. It's excusable now because, you know, I'm on an iPad. It's a bit difficult for me to draw. Right, so open switch. Here we go. There we go. And done. Right, so there's my circuit. I have, let's do a check. So I have my two cells. Let's count 1, 2, right? And it's alternating, right? So it's positive, negative, positive, negative. Now we know it's connected properly. Then we have our light bulb symbol, right? Good. Then we have our buzzer symbol, and then we have our open switch. What I would criticize myself on is this line is terrible. It's not acceptable. My lines are not straight, and it kind of looks unneat. But if you do it with a ruler, it will not look as shaggy or as unneat as mine. Right. Then here's another question. It says, draw a circuit diagram for the electrical circuit below. So now it's just asking you to take something or the more realistic representation of a circuit diagram and what they look like in real life, and then draw the symbolized version, the circuit diagram from it or of it. So we have two light bulbs, a cell, and it looks like a switch, and this switch is closed because you can see that this is connected here to this terminal, and then it's touching here on the other side, which means that the current can flow. Do not be distracted by this part. You can see that the switch is actually closed. Right, so let's do that quickly. So let's start with my, like I said, I always start with the power source. So in this case, it's a cell. Let's do it over here. Let's do it actually right underneath. Okay, so I have my cell. Then I'm going to go to my closed switch. All right, there it is. And then I'm going to go to my light bulbs. And because they're together, I'm just going to draw them that way as well. Let's do it here. 1 and 2. Okay, let's go back. And 2. And then close my circuit. All right, let's just make sure everything. So we have our, here we have our cell. Then we have our switch that's closed. Good. Here's our wire. And then we have our 2 light bulbs. And done. All right, and lastly, we have another question, question 8. It's asking us to use arrows to show the direction of the electrons that flow through the circuit below. Right, so the electrons, there's always debate around this topic, but I'm going to keep it simple here, right? The current or the electron movement is actually always from the negative terminal. So this is the negative terminal. This long one is the positive terminal. So the electrons are always moving from the negative terminal back around to the positive terminal, right? Or the negative charge is moving that way. So we have the flow of the electrons is always from the negative to the positive. So they're doing in this anti or counterclockwise direction, right? Like so. But there's always a bit argument because they'll say the conventional current, and I don't want you to get confused, I'm just saying this as a matter of fact, that the conventional current will move in the opposite direction. So it will flow from the positive side to the negative side. But we're not talking about conventional current now. The question asks us to show the direction of the electron flow, which will be from the negative terminal of a cell or battery all the way back to the positive terminal. Right, number 9 is, and lastly it ends, why do the electrons flow in this direction? And that's because the negative terminal is negatively charged, and so are electrons, and we know that if two particles have the same charge, right, so electrons have a negative charge, and so does the terminal, they will repel each other, which means the terminal will push the electrons away from it, causing the flow or pulsing of the electrons in this direction, in the direction away from the negative terminal, and the positive terminal will pull the electrons because its opposite charges attract, so they will pull the negatively charged electrons back towards the cell, and then this will continue the flows. It will repeat, and thus the voltage will continue pushing electrons through the circuit. Right, I hope that you found that helpful, and I hope that you never stop learning, right? Because as long as we're alive, we should always learn. That's what keeps us, I guess that's what makes us alive. And stay awesome. Until next time, see you.